yes, I come to you this evening bearing a gift. On behalf of UNSW and to mark this 21st annual President's Meeting, our gift to you is a tree. It's a tree that has been planted on behalf of each and every one of you here today. So if you want to visit this tree while you're here in Sydney, I must warn you, you're going to have to wear a wetsuit because the trees that we have planted are underwater. Let me introduce to you the species we have planted. It's called crayweed, and it makes beautiful golden-colored underwater forests like this one. Crayweed gets its name from crayfish, which is what we call rock lobster, because it loves it as a habitat. Abalone also love it as a habitat. There can be up to 10 times more abalone next to crayweed than next to any other seaweed. And crayfish and abalone are two of the most valuable fisheries in the whole of Australia. So this just goes to show how important crayweed is. So crayweed used to dominate along the coast of Sydney up until the 1980s. In those days, water quality was very different to what it is today. Back then, poorly treated sewage was dumped straight along the Sydney coastline. People remember surfing in places like iconic Bondi Beach, right next to what they called the Bondi Cigars, which was largely untreated sewage. Thankfully, things have improved dramatically since those days. We got deep ocean outfalls installed, and now the sewage is properly treated and disposed of via these deep pipelines. Despite the dramatic improvement in water quality, crayweed never came back to Sydney. So a few years ago, a group of us from UNSW and from the Sydney Institute of Marine Science got together to develop a way to try and bring crayweed back. Our method harnesses the power of seaweed reproduction. So what we do is we take crayweed from a nearby forest near Sydney, we remove the plants and we subject them to just the right level of stress so that when we place them back in their new habitat in Sydney, the first thing that the seaweed does to release all the stress is have sex. And of course, with sex comes babies. And I just can't tell you how excited we were, the whole team was, when we saw our first crayweed babies. That was back in 2011. Those babies have grown up and made babies of their own, and we're now into the 5th generation of crayweed populations in our first restoration site. And the wonderful thing is that our research shows that we're not just restoring crayweed, we're starting to restore the biodiversity that associates with it, the little creatures that live in amongst the crayweed. So this is a rare, good news environmental story that I thought was well worth shouting about. I think it's too easy for people to get disillusioned when they're constantly bombarded with stories of environmental collapse. In contrast, here's a story about a group of scientists that have effectively taken extinction, local extinction back and restored this new species. So to spread the news and to raise some funds to bring crayweed back to the whole of Sydney, we organized a crowdfunding campaign, which was extremely successful. We got enough funds to raise 8 crayweed forests, which we're now planting along Sydney. And now today, thanks to all of you here today, we have a 9th crayweed forest. It is the APRU crayweed forest, and we've planted it in your honor in iconic Bondi Beach. So this crayweed story, I think, is a very good example of how we can use science to devise environmental solutions. But I now want to tell you about another problem, a challenge at a bigger scale, and a problem for which we don't yet have a solution. Before this, let me tell you about a very special place. All of you here today will know about the Great Barrier Reef. But what you may not know is that Australia has another reef, and it is a much longer reef. It's 8,000 kilometers long. It is right next to where 70% of Australians live, work, and play. And it contributes $10 billion to the Australian economy every year. It's called the Great Southern Reef, and it encompasses the whole southern half of Australia. Now, what connects this Great Southern Reef are forests of seaweeds, species like crayweed, but also kelp forests that dominate along the entire 8,000 kilometers of coastline. Unfortunately, the Great Southern Reef, like its more famous cousin, is in deep trouble. And that's because the kelp has started to disappear near the warm edge of its distribution. My research aims to establish why this is happening. And what I have found is that one of the main reasons why the kelp is disappearing is because of the arrival of new tropical species. which have started to overgraze and eat the kelp. So in particular, it's plant-eating fish from the Great Barrier Reef. They're moving down, and they're starting to graze the kelp. Now, in their native coral reefs, these fish, they're herbivores. They play a very important role. They eat the seaweed that can otherwise overtake the coral. But in temperate reefs, like the Great Southern Reef, it is the seaweeds that are the foundation. They provide the habitat for hundreds of species. So when these new tropical vegetarian fish come in and eat the kelp, they're actually removing essential habitat and profoundly transforming ecological communities. This we now call tropicalization, and it's by no means unique to Australia. This happens wherever warm boundary currents push warm water from the tropics and towards temperate places. So off our coastline is the East Australian current that pushes warm water from the Great Barrier Reef towards Tasmania. But in Japan, it's a mirror image, and it's the Kuroshio current that does the same, but pushes the water north. And my research shows that very similar processes are happening in all these regions. The seaweeds are disappearing, and tropical species are increasing. Now, this tropicalization of marine communities is just one example of the brave new world that is emerging before our eyes. Completely new communities are emerging as many species migrate in response to warming, but others don't. So what can we do about it? In addition to the obvious and urgent need to reduce our carbon emissions, we also need to develop a radically new approach to conservation. We can no longer aim to retain what was historically there, because that's just simply not possible. New management approaches need to acknowledge the inevitable, that new ecosystems will continue to evolve with new properties. So in a way, this is not about fixing a problem, because it's not a problem that can be fixed. It's instead about finding ways to adapt to our new conditions. And we can only do that through a better understanding of the science that is driving these changes. Universities can and should play a leading role in helping us to navigate through this new and challenging paradigm. Thank you.